Okay, so let's look at these last few problems. So we have an integral of 2x divided by x squared plus 1. So when we look at a fraction like this, the thing that we want to get rid of the most is the denominator. So we're going to set the denominator, that x squared plus 1, which looks a little bit scarier, equal to u. So we have u is equal to x squared plus 1. du is going to equal to 2x dx. So looking at this, I have u, x squared plus 1. So this is going to all change. And then we have what's left over, dx and a 2x. Thankfully, I have a 2x dx here, so I know that those are going to be what I need. So we have the integral of, in the denominator, we have u now. Instead of 2x dx, I'm now going to have du. And then I have nothing in the numerator, so I'm going to put a 1. You could put the du there, but it still looks horrible. So now we're doing the integral of 1 over u. The integral of 1 over u is the same thing as the natural log. We want the absolute values here to make sure that u won't be negative. And then we are going to change it back. So the natural log of the absolute value of x squared plus 1 plus c. U substitution takes things that look kind of scary and turns it into things that are a little bit easier. So the one thing that we need to be careful of is when we have bounds. So if we have a definite integral and we do U substitution, we just want to make sure that we are doing the right notation. So if I change this at all, or if I put an equal sign saying it's equal to something else, I need to make sure that there are bounds on my equation. So we did this one a little while ago. We said u was equal to 2x minus 1. So I know that I'm looking at the integral of the square root of u, and then I'm going to pull stuff from that last problem. We get that 1/2 du. Okay, but an indefinite integral and a definite integral are not the same. An indefinite integral is talking about the area under the entire graph versus a definite integral, which is only looking between 0 and 1. So I need to make a lower bound and an upper bound. When we do this, our lower bound and upper bounds are going to be based off of our u equals equation. So our lower bound is x equals 0. That 0 is an x value. So what we're going to do is take that x value, plug it into our u equation, and we are going to get a value out. So u is equal to 2 times our x value minus 1. So u is equal to 0 minus 1, or just negative 1. So the lower bound on this is going to be negative 1. We're going to do the same thing for the upper bound, but this time we're going to look at x equals 1. So u is equal to 2 times 1 minus 1. So 2 minus 1. So u is equal to 1. So when I change this to u's, we are now kind of shifting what our bounds are. So when we do the integral of the square root of 2x minus 1 dx, we're going to look between 0 and 1. That same exact function to give us our area is going to be the integral from negative 1 to 1 of the square root of x times 1/2. Those give us the same thing. So if we change it and we set it equal to, we have to change the bounds. There is one way around this, and that is doing the integral, the indefinite integral of the square root of 2x minus 1 dx, doing all of the u substitution like normal. We got 1/3 times 2x minus 1 to the 3/2 plus c as our final answer, and then use that to do our bounds. So then I can go over here and say, hey, well, this equals 1/3 2x minus 1 to the 3/2 plus c, evaluated between 0 and 1. And this is just kind of getting around having to refine the bounds, but finding the bounds is not difficult. we've already done the work for finding the equation between the two, so now we're just solving for that integral to make it consistent.